Good morning. Today is an example of example number 4 on the partial fraction decomposition practice. And if we look closely at example 4, you're going to notice that the degree of the numerator is less than the denominator. So we don't need to do long division and we can proceed. Okay, so let's look at the next step. The very next step is going to be to factor the denominator. Now, we're going to notice that there is a greatest common factor, which is an x, that we first are going to take out. When we take out an x, what remains is 3x squared plus 7x plus 4. Now, it's imperative that you try to factor the remaining trinomial, because if it does factor, that means we're going to have 3 fractions. So we can factor 3x squared plus 7x plus 4 into the quantity 3x plus 4 times x plus 1. At this point, there are 1, 2, 3 factors in the denominator. Therefore, there's going to be 3 fractions. So I'm going to put a over the first factor, b over the second factor, c over the third factor. At this point, I'm going to add the fractions on the right together. I'm going to do that by getting a common denominator. So that gives me a times the quantity 3x plus 4 times x plus 1 plus b times the quantity x times x plus 1 plus c times the quantity x times 3x plus 4, all over the same denominator. At this point, we have 2 fractions equal. We can set their numerators equal because the denominators are equal. So now we're going to go to this step here. All right, and this is where I'm going to do all of my work. I'm going to take this equation and I'm going to try to solve for a, b, and c. And the first thing I want to do is let x equal something super easy so I can solve for one of the missing letters. So when I look at this problem, I think it's really easy to let x equal 0. If x equals 0, that will eliminate b and c. You can see that those will drop out. So if I let x equals 0, I can then solve for a. So let's do that together. Okay, if x is 0, b and c are going to drop out. So I'm not even going to write those in, but I'm going to plug 0 in for x here and here. So this gives me 8 equals a times 3 times 0 plus 4 times 0 plus 1. That's going to give me 4a equals 8, and so I know that a equals 2. Okay, let's try to find another easy x value. Now let's let x equal, I'm thinking -1 might be a good idea, right? Because if I let x equal -1, if I put -1 here and here, do you see how that'll make a and b go to 0, and that'll make me able to solve for c. So let's do that. So let's say that 8 equals, okay, so again, a and b are going to drop out, and I'm going to put the -1 right here. So c times -1 times 3 times -1 plus 4, and that gives me that negative c, right? Because if I add this together, this is going to be +1 times -1, and then c is going to equal -8. All right, so I know my c value, and the only thing that remains is for me to solve for b. So in order to solve for b, I want to try to cancel out a and c, and it looks like if I make x equal to -4/3, okay, -4/3 will cancel out c and a. So let's try that. Let's let x equal -4/3. Okay, and let's see if we plug x as -4/3 in, what's going to happen. Now remember, a and c are going to drop out, so there's no point plugging in -4/3. Let's plug it just in here. So that gives me what? That gives me 8 equals b times -4/3 times -4/3 and I'm going to call 1 3/3. That makes sense. So that's going to give me, if I follow my order of operations, this is going to give me negative 1/3. But when I multiply, I'm going to get positive 4/9 times b. Now to get b by itself, I'm going to multiply by 9/4 on both sides. Cross simplifying allows me to know, and again I'm going to cross simplify here, that b is equal to 18. So we have solved our mystery. A is equal to 2, c is equal to negative 8, and b is equal to 18.